Hello, my dear friends. In this discussion, we are going to look at the law of mass action. This is, of course, very important while doing chemical equilibrium problems. So, if we consider a reaction where A plus B are reacting in a reverse reaction to give C and D. Take an example that we are having D moles of D and small c moles of C, then B moles of B and A moles of A. So the law of mass action says if we are to determine the equilibrium constant, for example Kc, in terms of concentration, this is going to be the concentrations of product and divided by the concentrations of reactants. But this law helps us to determine the exponents here. So it tells us that once we have Kc in this form, then these concentrations are going to be raised by their respective stoichiometric factors. So for D, I'll have D here, I'll have C here, I'll have A here, I'll have B here. So that's what it says. Then let's look at an example. In an example of a reaction such as hydrogen, okay, taking on chlorine gas, giving us hydrogen chloride gas. So we can do the balancing. This becomes 2. So you'll find that if we want Kc in terms of concentrations of these gases, then we are going to have at equilibrium, this being the equilibrium constant, we shall have the concentration of hydrogen chloride gas raised to a power of 2 divided by the concentration of hydrogen raised to a power of 1, then times the concentration of chlorine gas raised to a power 1, because we have stoichiometrically we have 1 here and 1 more of chlorine. And if we talk about, since they are gases here, so, we could also give it in terms of partial pressures. So the equilibrium constant can be given in terms of partial pressures, and that will still remain the partial pressure of the product. We are going to have Kp equivalent to the partial pressure of the product, which is hydrogen chloride gas, again raised to a power of 2 divided by the partial pressure of hydrogen raised to a power of 1 times the partial pressure of chlorine raised to a power of 1. And then this and that are all obtained because we have applied the law of mass action. So for partial pressures, once you are given the temperatures and you're given the pressures, for you to get the partial pressures, you could be given the temperature, you could be given the moles, and volume. So you are able to have the concentration, obviously, in terms of number of moles per unit volume, and then it is from there that you apply the universal gas law, whereby PV is equal to nRT, okay? And then from here, you are able to say that P times V, okay, let's take it to the other side so that we have it in terms of concentration. So we can say P is equal to N out of V, then RT, and then this is going to be the concentration. So that pressure will be the concentration times RT. So the moment you raise it to, for example here, power 2, this will be R squared, T squared. Obviously the temperatures, you're going to be having it in terms of, it is going to be in terms of Kelvin. Then this R, you always have that R, okay? R can take a value equivalent to 8.3145. R takes a value of R is equal to 8.3145, and this is in joules per mole per Kelvin. But also R can be in terms of 0.08206 liters, okay, liters, and this is going to be in terms of atmospheres per mole per Kelvin. So you're able to substitute it in here. You have the concentration, and then you'll be able to determine the partial pressure. Then you go ahead and get Kp. That is very important. Now, in this question, we are being asked to write the expressions for Kc and Kp for the following reaction. Now, we said that the equilibrium constant Kc, when talked about, or when they ask you to write it, they are trying to refer you to using concentrations. And when you meet Kp, they are referring to equilibrium constant in terms of partial pressures of the gases. So let's write this and have it. So let's balance this equation. First of all, we are going to balance this equation. So we are going to put nitrogen is 2, okay? Then this side, hydrogen becomes 2, and the other side is 6. So I can put 3 there. So meaning nitrogen remains with 1 here. Equilibrium constant in terms of concentrations. So we're going to write Kc. Kc is going to be, now remember we get the ratio of the products divided by the reactants. So the products here, we have nitrogen, ammonia, divided by the concentration of hydrogen times the concentration of nitrogen. So let's raise these concentrations to the stoichiometric factors in this reaction here. So ammonia is having a 2, so we shall raise it to power 2. Nitrogen is to power 1, and hydrogen is power 3. So that is the answer. That is in terms of concentrations. Let's talk about Kp. Kp, we are talking about equilibrium constant in terms of partial pressures. So Kp, therefore, will equal to the partial pressures of the products divided by the partial pressures of reactant. So we are going to be talking about P of ammonia, the partial pressure of ammonia, and we raise it to a power that we are picking from the stoichiometric reaction. So this is going to be 2. We divide this by the partial pressure of hydrogen to power 3 times the partial pressure of nitrogen, power 1. And that gives us the solution to this problem. Those are the equilibrium expressions for Kc and Kp for this particular reaction. Now let's look at this question. The nitrogen reacts with chlorine to produce nitrogen trichloride. At equilibrium, the concentrations of each gas were found to be the concentration of nitrogen at 0.15 molar, the concentration of chlorine 0.25 molar, and the concentration of a nitrogen trichloride 0.5 molar. So we are required to calculate the value of equilibrium constant Kc. So first of all, before we do all this, we need to understand these concentrations are in moles per liter. So in 1 liter of solution, we are having there 0.15 moles of nitrogen. We are having 0.25 moles of chlorine. We are having 0.5 moles of nitrogen trichloride. So let's look at the reaction. That is the equation for the reaction. So we have nitrogen reacting with chlorine to produce nitrogen trichloride. So when we are to balance this, let's balance this equation. So we put a 2 here, and this becomes, chlorine becomes 6, so we put a 3 here. So this remains with a 1. So what is Kc? Kc, we said ratio of concentration of products divided by the concentrations of reactants. So the product is nitrogen trichloride divided by the concentration of nitrogen itself and concentration of chlorine. So we are raising this to their stoichiometric powers, and this is 2, chlorine is 3, and this is 1. So we're just substituting the values here. So nitrogen trichloride is 0.5. We square it, divided by 0.15 power 1. Then we are multiplying it by 0.25 power 3. So putting this on my calculator is giving me Kc equivalent to 106.6 recurring. So that is how we can calculate the equilibrium constant in terms of concentrations. And if given the partial pressures in terms of atmospheres, we are able to look for Kp.